Okay, so in this example, they're giving us a function and they're telling us this function has a maximum value at x is -3. And there's two parts of this question, having to find a. As we can see here, there's a variable here, a. We don't know what that is. And also they want that's part A, or part one of the question, and part two is finding the range of values of x, where this is a decreasing function. So because they're telling me this is a maximum value, usually at a maximum value we would have a gradient, basically a stationary point. Not all maximum points would always be a stationary point, but in this example, because this is differentiation and it's in the differentiation kind of chapter, so we're just going to say, okay, well, most of the functions we work with in this course, we're going to assume that turning point, or that maximum value, is going to be a stationary point. So in order to continue here, first I'll have to derive, so dy over dx, and then pretty simple, this is straightforward. This is just 2 times a, so 2ax, and then -9, and the other terms disappear. So I know this is my, let's say, my gradient function, and at the maximum point at -3, obviously well, not obvious, but that is something that you should know. At that maximum point, our derivative will be equal to 0, because that maximum point is actually a stationary point. So I will just equal this to 0, and I'm going to replace all the x's with -3. So let's do this in a nice color. 3 and the -3 I'm putting in there, plus 2a, I'm trying to figure out what a is, and then -3 minus 9, and this is all equal to 0 because it's a stationary point. And then from here, -3 times -3 is going to be 9 times 3 is 27. And this is going to be -6a minus 9 is equal to 0. And now I can pretty much just solve a. I'll take a to the other side, then it's positive 6a. 27 minus 9 is going to be 18. So just divide both sides by 6, and a will be left to be 3. So now I know that a is a 3. So we found a, so yay for us. And then next we just have to find the range of values where x is a decreasing function. So I have to stop saying obvious, but when a function is decreasing, let's say this is now a positive cubic function, so just roughly it might look something like this, and it's asking us that the part where this is a decreasing function. So any time this function is decreasing, it'll probably be between those 2 points, because it's going down. So that's a decreasing function. This side it's increasing, so it's increasing there and it's increasing there. So these don't necessarily have to be stationary points, but in this case we know it will probably be, because they did tell us that we have a maximum value. So my assumption is that this point here, this x value down here, will probably be -3. But now we need to find all the values where this function is decreasing. Now, obviously, me and the obviously again. So the derivative in this gradient function will tell me obviously everything about the gradient. So all I can do, or what I can do, is I can say, well, for a function to decrease, dy over dx must be decreasing, so that must be smaller than 0. So anywhere my derivative is smaller than 0, I know this function will be decreasing. So I'm just going to put in the 3 in there. So I worked out this is my derivative. So I'm going to write here 3x squared, and then the 3 times the 2 is going to give me a 6. So plus 6x minus 9. And this all has to be smaller than 0. If they ask me if when it's an increasing function, then I would have just switched the sign around and said, well, the derivative had to be bigger than 0. So I can solve this. I can just divide by 3 on both sides. Well, not both. Yeah, well, everywhere divide by 3. And I'm left with this. And now I can just factorize. Some of you will have calculators that just does this for you. But just interestingly enough, finding the... I know I said we're going to decrease... We want the derivative smaller than 0. But something to keep in mind is I'm just... From here on this way, I'm just trying to find critical points. I could have made this equal to 0 as well. I should just know that the whole derivative should be less than 0, and we're going to do a little sketch on the side now. But I am definitely going to find that if this is if this is a max value, I'm going to assume that one of these will be like x plus 3 or something. But let's just see how that works. So there's x, and I know the 3 and the 1 will have to work, and this has to be a plus 3 and a minus 1. Now these are my critical points. Now I can't... What I should know is I can't do the same thing as with a null rule and now say, well, x plus 3 has to be smaller than 0 and x minus 1 has to be smaller than 0. This is not going to work for us. Because with the null rule, if I had two things multiplied and they're equal to 0, then one has to be 0 and the other one... Well, either one is 0 and this one isn't. But then one of these has to be 0 for the answer to be 0. But for inequality, that's not really the case. I can have basically any number here and any number here. So if I have two negative numbers, then this will be a positive value. But if I had any negative and any positive value, you know, this will always be smaller than 0. So it's not the same thing. I'm trying to explain that from here on out, I just have to know that I'm trying to find critical points by factorizing, and this is not what I'm going to do. When I get to this point, basically I just know, well, x, one critical point, I can maybe make CP, one critical point is going to be -3, and we know this because that is the one they gave us, and the other critical point is going to be x is equal to 1. So those are the two critical points, and to solve this inequality, I'm actually going to have to do a little bucket method drawing, where on the side here, I know this is a parabola, and it's a positive parabola. So I'll draw a little graph here, and my critical points are -3 and 1. So -3 is here, and 1 is there, just because obviously negative numbers are this side, 1 is on the other side, positive numbers. And I know that my function, or the derivative, should be smaller than 0. So obviously that is above 0 and this is below 0. So everywhere where this function or this parabola is below 0, this is kind of where my function will decrease. So for all the values that x is smaller than 1 and bigger than -3, this is now my answer. And if I were to look at my original function here, it made sense, because I said, well, look, we're going to have the maximum value here, and that's going to be -3, and the minimum value here, because this is also a stationary point, the minimum value here is going to be, well, x is equal to 1 at that place. And it's a decreasing function in between these 2 points. So everywhere from x -3 to x equal to 1, this is a decreasing function. So the range of values where this function is decreasing is, well, x must be bigger than -3 and smaller than 1.